What's good, YouTube? It's Almond with the Sauce, and I'm back with another video. This video right here is part 2 to the part 1 where we learned about how to find the arc length and the sector area of a circle. So if you haven't watched part 1, go make sure to check that out first and then come back to this one. All right, so with that being said, let's not waste no more time. Let's see what we got. All right, so it says, find the length of arc JK in circle M. So they want us to just find the distance along the circle from J to K. All right, so let's first start off by talking about what we know and what we need to know. So if we're trying to find the length of arc JK, let's let that be X. I'm gonna say the length of arc JK. And just by looking at the diagram, we know that our radius is 8 and our central angle theta is 110 degrees. All right, and so the way to think about it is to just think of, again, that arc length is a fraction of the whole circumference, so we can just let that be a fraction. And again, we know circumference, which is the distance around the circle, is 2 pi r, so I just put 8 in for r since that's our radius. All right, and so in that same manner, just how the arc length is a fraction of the circumference, that angle theta, that central angle, is a fraction of a full revolution, which is 360 degrees. All right, so after that, all we can do is just cross multiply and then solve for X. All right, so now in my calculator, you can do it one of two ways. They might ask you to leave your answer in terms of pi, which means leave pi in your answer, but don't put it in your calculation. So I'll just show you how to do it like that. And so what you do is you multiply by everything else. So across the top, I got 2 times 8 times 110, which is gonna give me 1760. And then again, I'm leaving my pi right there over 360. And so 1760 over 360, if you put it in your calculator, you can see it reduces to 44/9, but we still got that pi right there. And then again, if our radius is in meters, then our arc length is also in meters. And X is by itself, so that's how you know you're done. All right, so in this next example, it says find the area of the shaded region inside circle T with a radius of 14 centimeters and a central angle of pi over 3 radians. Now, just to make sure y'all understand, pi over 3 radians is a portion of, instead of the whole 360 degrees, this time it's out of 2 pi radians. So when we set up our proportion, this pi over 3 will be out of 2 pi. So let's go ahead and start with what we know. We know our radius is 14. We know our theta is pi over 3. And then we're gonna need to know the area of a circle, which is pi r squared. So pi 14 squared. And then the area of the sector is what we're trying to find, so we can just let that be X. All right, so now let's go ahead and set up our proportion. You know, the sector area is a fraction or a portion of the whole area. So we can say X over pi. So instead of saying 14 squared, I'm gonna just say pi times 196. And then that's gonna be equal to that central angle, which is pi over 3, out of 2 pi radians. All right, so just like last time, all we gotta do is cross multiply and then get X by itself, and then we'll be done. And then for this 196 divided by 3, I can just leave that as it is. All right, so now if we wanna get X by itself, we just divide both sides by 2 pi. And then on the left side, the 2 pi's cancel out. So we do have X by itself, which is what we want. And then on the right side, we're gonna kind of have to be careful. I noticed that I got a pi squared over pi. And if it helps to write that out, you can just think of that as pi times pi, which is pi squared over pi. And then you can see that one of those pairs of pi's cancel out. So you're left with 1 pi on top. So I'm gonna have 1 pi on top. All right, and for this this part right here, I'm gonna write 2 as 2 over 1. And then you know how multiplication and division are the inverses of each other. If I have 196 over 3 divided by 2 over 1, That's the same thing as multiplying by the reciprocal. So that's really like multiplying by 1/2. So I can do that off to the side. 196/3 times 1/2. And you can see that that'll just be equal to 196/3 times 2, which is 6. So for x, I'm going to be left with pi times 196/6. And then if I take half of both the top and the bottom, that'll leave me with 98/3. And then I got to remember my pi. Now, we can't forget units either. If it gives us a radius in centimeters, we're talking about area, which is going to be in centimeters squared because it's 2 dimensions. All right. All right, so for this third example, it says you are designing a basketball court for your school's gym and need to send in dimensions for the key. So for y'all that don't know, the key is just like this part of the basketball court where this part right here is a full circle. So it says find the length of the arc formed by the semicircle. So we're just trying to basically find this length from A to B. So just like last time, we just start off with what we know. If we let the length of arc AB be X, since that's what we're trying to find, and then it gives you that the diameter of the circle is 12 feet, but we need the radius, which is just half of that. So our R is going to be half of 12, which is 6 feet. And then this part could be a little bit tricky, but theta this time is actually going to be half of the circle, because you know a semicircle just means half of a full circle. So half of 360 is 180, or you could do pi radians, either way. And then so we're going to use those to set up our proportion. So if we let x represent our arc length, that is a portion of the whole circumference, which is 2 pi r, and we already know r is 6. And then also we can let that theta, that 180 degrees, be a part of the whole 360. And by now hopefully you realize that you can just take the whole circumference, and since it's a semicircle you can just take half of the circumference, but I'm gonna do it this way still, just so you can see how to do it, you know, the way that most of them will be done. All right, so after this, you just cross multiply. So I'm gonna have 360x equals 180 times, I'm gonna leave my answer in terms of pi still, 180 times 12, and that's gonna get me 2160 pi. So x is gonna give me, I'm gonna type in my calculator, 2160 divided by 360, 6, and then don't forget that pi. Now, let's talk units. So we are talking about the length of a one-dimensional shape or a one-dimensional quantity. So that's gonna be in feet. All right, not feet squared, because we're not talking about a two-dimensional quantity. We're just talking about a length. So x equals 6 pi feet is our final answer. So for this last example, I'm gonna just insert it because I don't feel like writing it down. But it says Ashley has a sprinkler that has several varieties of coverage. The quarter circle sprinkler head sprays water at a distance of up to 20 feet from the head. What area will be covered by the spray of the quarter circle sprinkler head to the nearest square foot? All right, so let's draw a picture, obviously. So she's got a sprinkler system, which I don't know what it looks like. It's a quarter circle sprinkler head. So that means when it sprays water, it covers a quarter of a circle, and it sprays water of a distance from up to 20 feet. So it goes 20 feet in all directions. So it's like, and then that goes out 20 feet as well. So they want to know what area will be covered by the water, basically. What do we know? We know our radius is 20 feet. And then we know, what else do we know? Our theta is a quarter of a circle. So a quarter of 360 is 90 degrees. And then, so what are we trying to find out? We're trying to find out the area of this sector. So I'll let x equal the sector area. And then we know the area of our circle because that's pi r squared. So now, like always, we just set up our proportion. So the area of that sector is a portion of the area of the circle. And instead of saying 20 squared, I'm gonna just say 400 equals, now our theta, which was 90 degrees, is a quarter of 360. Now again, I know you could just take the whole area of the circle and then just take a quarter of it or divide it by 4, but I'm just doing it this way so you can see, you know, the steps on how to do it. And then we just cross multiply like normal. So now I got 90 times 400 times pi, so that's 36,000 pi. And then I can just divide by 360 on both sides to get x by itself. All right, so my 360s obviously cancel out, and so I'm left with x equals 3600 over 360. Well, I can just cancel out 360, and I'm left with 100 on top. So my area is 100 pi, and then feet squared, since we're talking about area. And I know they did ask for it in the nearest square foot. So what you could do is just take 100 and multiply by pi and then round it to the nearest whole number. All right, so that'll just give me 314 feet squared. And that's it. All right, so thank y'all for watching the video. Hopefully it helped. If it did, make sure y'all leave a thumbs up. If y'all have any questions or suggestions about what I should do in the future, make sure y'all drop a comment below. Make sure you subscribe if you're new. And with that being said, I'm out.